Yeah, hi. So Stephen Frost, and I'm going to be talking about identifying slow queries and some ideas about how you might be able to improve on them. As we go through, feel free to ask questions. Just speak up. I'll definitely roll with it. I'm pretty good at that. Just to get into it, a little bit about me real quick. I'm Stephen Frost. I'm the Chief Technology Officer at Crunchy Data. I'm also a committer, major contributor. I've worked on row-level security, column privileges, the role system, contributions to various other things. So, been around Postgres for quite a while. Some of you might have heard we were on the panel yesterday. But that's enough about me. All right, so there's a few different ways to figure out what your slow queries are in your database. One of the ways that I'm going to talk about a fair bit here is logging, right? So one of the tools that's really good in Postgres is our logging system. If you're not monitoring your Postgres logs, you really should be, because not only are you going to find slow queries in there if you go through some of the things I'm going to talk about here, but you're also going to see things like queries failing and queries having issues. You can also see things like when a lock is held for a long time, you can see that in the query log, which is really, really helpful. I'm going to talk a bit more about that as we get into it. So I'm going to cover a number of the different options for postgresql.conf. These options can all be also set through the alter system command. I'm kind of old school. I like you just hacking up postgresql.conf, but you can also use the alter system to alter system command to set those parameters. Talk a little bit about log analysis. So PG Badger is a really nice tool for doing log analysis, and I'll talk a little bit about that. May even pull up a little demo of it. We'll see how well the Wi-Fi wants to play with me today. And then we're also going to talk about another way to look for your slow queries, which is called pgstat statements. pgstat statements is a module that's included with core Postgres. You have to actually go enable it early on. So you have to set it up in postgresql.conf, and then you have to create the actual extension. But then you'll be able to monitor all of your queries through pgstat statements. So that's the other really great way to find your slow queries in Postgres. So those are the two main things, two main approaches for finding slow queries. So when it comes to logging, I'm going to kind of go through each one of these logging parameters here that are particularly relevant to finding your slow queries. The first one is logmin duration statement, and then I'm not going to read them all because I'm going to go through each one. But if you're looking for kind of the short list of things to think about when you're talking about logging for Postgres, these are ones that I always go and set and make sure that are set to reasonable values, so that I'm tracking the information that I need to be able to find my slow queries and to be able to work on them. I'll also make sure this slide deck's online somewhere for you all afterwards. And if I don't, you can yell at me. So the first one is a really great option that's been added and exists in kind of all modern versions of Postgres these days. It's called logmin duration statement. So if you set this to 0, every single statement sent to Postgres is going to be logged. Right? That can create some back pressure, so I wouldn't necessarily, if you're not logging statements already today, I wouldn't just go and enable this on a production system that's busy, right? This is one that you may want to look at enabling and setting to, so the number is in milliseconds by default. You can pass in a parameter to it if you want, though, but by default it's in milliseconds, and I would say, if you're just starting out, set this to 5 seconds or 10 seconds or something, initially, right? And get a feel for what are the queries that are taking longer than that amount of time. If you start in on a system that's really, really busy and you set it right to 0, it's going to suddenly start dumping tons and tons and tons of logs into your log files, and that can create some back pressure and might have an impact on production. But in general, if you set this to something where the amount of logging is pretty reasonable, I've found that it doesn't have very much of an impact on performance. As for what exactly is reasonable in your environment, that's going to really depend. And what it depends on is how long your queries are taking and how many queries you're running. I like to try to make this pretty tight. So if you could set it to 10 milliseconds or 50 milliseconds, like that's good stuff, because the more, the lower this number, the more queries are going to be logged, and you're going to have that much more information about what's going on in your system. The big thing about using log min duration statement versus some of the other ones, like log statement and log duration, are that log min duration statement actually includes the duration on the same line. For reasons that boggle the mind, and actually go back to that idea about yesterday about maybe there are some options we should remove, I think one of the options we should remove is log duration. Because log duration actually logs the duration on a separate log line. And when you have, 100 different backends all writing into the log, it's not clear which one that came from. You have to go actually figure it out by the process ID and whatnot, so it's kind of painful. So I don't think log duration is terribly useful, frankly. I like log min duration statement a great deal more. Here's an example of what that looks like. So here you can see that the duration logged was 1,001 milliseconds from a running select PG sleep. So PG sleep of 1 is just a command that says sleep for 1 second. So this is obviously just a kind of a demonstration. On those really, really busy systems, sometimes you want to log those queries even if they're running quickly for various analysis. But if the system's too busy, you can't do that because logging every single query is going to back things up. So what we have here also is a log min duration sample, and you can set a sample rate. So what this will do is this will log a sample of the queries versus every single query, right? So by default, it's set to 1, but you can change that and adjust it if you need to. Sorry about that. So if the query ends up exceeding the value set in log min duration statement, that'll end up taking precedence and it'll log that query anyway. So this is if you want to have it, you can set those independently. So you can get like a sampling of queries that take a long time or a short time, and then you can have your other queries, the longer ones, always logged. Another really important thing for logging is setting a log line prefix appropriately. A lot of distributions do this for you already. They set a pretty reasonable one. But if you're coming from the source code, the default one is kind of garbage. So I definitely recommend setting this to a value. This is one example. This is actually an example I pulled from PG Badger about the different parameters to include. But you can adjust this, depending on your interest. One thing I do want to point out here is you definitely want a timestamp and a process ID. And then the other one is application name is really, really handy. So one of the things that's really nice in Postgres is that as part of your connection string, you can set an application name. So if you've got a variety of different systems and applications connecting into Postgres, in your connection string from those different applications, you can set an application name, and then that'll show up in here, which is really, really nice. So that's something that I would certainly recommend you consider taking advantage of, because then you can also see what system it was, or what application that particular query was coming from. You may know that from other information based on the source IP or things like that, but you can get even more granular, right? You could have like different parts of your Django app or whatever, like different modules of the Django app having different application names if you want, because you can also set that on the fly, right? You don't have to set it only on connection. You can change it on the fly too. Another really important one is to log your checkpoints. So one of the things that you can run into at times is you end up with queries being slow, but it's not actually the query that's slow, it's because of other things happening on the system. And if you are logging things like checkpoints, you can see if there's some correlation there. So logging of checkpoints will log when and why the checkpoint started, when the checkpoint completed, and some general statistics about the checkpoint. So here you can see the number of transaction logs that were added and removed. So this, things like transaction log files added and removed will give you some indication of how much write activity is happening on the system. You can also see how long it took Postgres to write and sync that information out, and the total amount of time overall for the checkpoint. So that's all really useful information, and you can also kind of, again, back that out and say, okay, if a bunch of my queries were suddenly slow when this checkpoint was running, that's really useful information. The other one that's really important here is this checkpoint starting. So this immediate force wait is not something you should be seeing very often. That's usually if somebody goes in and explicitly runs a checkpoint command, or if they came in and did like a create database or one of the other operations that implicitly requires a checkpoint to happen. And so those are specifically cases where, like, if you see an immediate force wait and suddenly the load on the system went up quite a bit, that's because Postgres is doing a forced immediate checkpoint where it's going through all of shared buffers and writing out all of the dirty buffers right then as fast as possible. And that's, very expensive, right? And can end up causing an I/O conflict, right? Or I/O congestion, I should say. So this is why it's really helpful to log checkpoints. The other reason to log checkpoints is because if you see checkpoints starting due to log or due to xlog or due to wall, what that's telling you is that your max wall size rather is not big enough, right? Max wall size is something that if you generate that amount of write-ahead log within the default checkpoint time, which is 5 minutes, then Postgres will have to immediately do a checkpoint, which again means running through all of shared buffers and writing it all out quickly in order to be able to get back some space in the write-ahead log area to be able to continue writing. So I'm not going to go super deep into how wall and all of that works, but if you have questions about that, let me know. But if you see checkpoint starting due to immediate force wait or due to xlog, you want to look at maybe adjusting your parameters or talking to whomever is going around running checkpoint, because that can end up being a problem. I always recommend logging connections and disconnections to Postgres, so you have an idea about how frequently connections are coming in and how long they're lasting. One of the other things to be aware of is that new connections to Postgres are relatively expensive. Right? So sometimes, if your application isn't performing very well, it's not actually the queries at all. It's because you're like connecting and disconnecting from the database for every single query, and that's very expensive in Postgres. So I definitely recommend using some kind of connection pooling. Typically, my preference is PG Bouncer. In fact, if you can get PG Bouncer to work in transaction mode, that's awesome. It does mean that there are some things you're not able to do with it. But that's something I certainly recommend folks look at. Application level connection poolers are also fine. They're generally okay. I find PG Bouncer to be better personally, but nothing wrong with them in the grand scheme of things. But definitely, you want to make sure that your connections are lasting some amount of time. You don't want to have constantly be reconnecting to the database. Part of the reason for that is that whenever you connect to a Postgres database, you spawn a new backend, and that backend doesn't have any anything cached, right? And so some of the stuff that Postgres does right away, as soon as you start issuing queries, is we have to then go look things up in the catalogs and go get that information back off of disk, and then we will cache it for that backend, right? And that means that subsequent queries will be faster, which is great. But if you're constantly disconnecting and reconnecting, then you're constantly losing that cached information on that reconnect. So that's just for a bit of background on why it is that that there's a performance hit from constantly disconnecting and reconnecting. It's because of that that cache that gets filled, which is called the sys cache and the relation cache. If you're curious. Next one is really good, right? Log lock waits. So in Postgres, we have something called a deadlock detector. Deadlock detector runs after waiting on a lock for 1 second, okay, by default. So whatever deadlock timeout is set to, which is by default 1 second, that's how long Postgres will wait after it has attempted to acquire a lock and had to wait. One of the things that will happen, though, is if you enable log lock waits, then after that 1 second timeout, Postgres will write into the log all the information about that the waiting that it's doing, right? So you'll see here which process is waiting on the lock, right? And what it's waiting on, right? What kind of lock? So this is a share lock on this transaction, right? And it'll also tell you what process is currently holding that lock and what other processes are currently in the wait queue for that lock. So it's possible that your queries aren't actually slow, right? It's just that they're having to wait on locks. And that's where logging of lock weights is really helpful. If you're finding that your queries are running, 300, 400, 500 milliseconds, and you're not actually getting to get this information, and you think it might be a lock, you could reduce the deadlock timeout amount of time down from 1 second if you wanted to get the, to see this log lock weights firing. I do caution you though, running of the deadlock detector is relatively expensive, right? And from a CPU computation perspective, because it's got to run through and figure out, are there any deadlocks between any of the locks that are currently being held. So that's a relatively expensive operation. So I would not set this down very low. Don't raise this value. I've seen people raise deadlock timeout, and I think they thought it was because it would make the deadlocks that they are seeing in their system go away. That's not how that works. Right? If you're seeing deadlocks, you need to go fix those deadlocks. That's what you need to do. Raising this value is not going to fix it. It's just going to make it take longer before Postgres realizes the deadlock is there. Right? The whole thing about a deadlock is that you're in a deadly embrace and you can't make progress. So don't raise that value. But lowering it makes sense in some cases, particularly to see these log lock weights. Another one that's really, really useful is logging of temp files. So temp files are things that Postgres will create during a query run, right? So in the event that we need to spill the disk for a hash join or a hash aggregate or a sorting operation or any of those, we'll spill the disk, right? And what that often means is that you have work mem set lower than what would be helpful to Postgres. That's why it's spilling the disk, right? If work mem was higher, and I'll talk a bit more about work mem later, but if work mem was higher, right, then you probably wouldn't see it spilling the disk. There are some cases where we have to go to disk, things like a materialized node, but in other cases we don't need to spill the disk. We are just doing so because we don't want to exceed what the work mem value is. So Bruce touched on this a little bit earlier about things like in hashing operations, we'll actually just default to using more memory now because it's just so much of a difference, right, between having a hash join spill the disk versus having it all be able to run in memory. So logging of temp files is good. This recommendation of 4 megabytes isn't bad. I mean, I like to actually set it down to 0 personally because we don't write that many temp files, and I'm just always curious about what's writing temp files. But don't be too concerned if you see temp files being written. Again, sometimes they're required for a query. But if you see really large temp files being written and your query is going really slowly, then that may be something that you want to go look at and figure out what's going on. And the other nice thing about this is that when it does that, it's going to log what that statement was that created that temp file. So you'll know which statement it was. And again, if you set application name or something else, that can make it easier for you to go figure out where that query is coming from. Yes, Bruce? No, sorry, I didn't mean to say that as a default. There's a bit of a discussion between myself and Keith Fisk in particular about what value to set this to. Okay. This is his default. Yeah, this is his recommended value. my recommended value is 0. So, but he's the one who he's been maintaining these slide decks. So, yeah. Anyway, sorry. But yeah, though there is not a default. By default, we don't log temp files, which I don't agree with personally, but that's just me. Another one that's really good is auto vacuum min duration. So this one tells you about when auto vacuums happen. You can also go look in pgstat user tables and see when the last time something happened on the system in terms of an auto vacuum run vacuum or a auto analyze happened on the system. But if you log this, you're going to get all these other stats too, right? So I like setting this to 0 so you always are getting information about what vacuuming is happening on your table. And while it's hopefully not too impactful on your system, it can be, right? Now that said, vacuuming is really, really important. You should not turn it off, right? I know a lot of people see vacuum running all the time and they're worried about it. That's not bad, right? The reason that vacuum runs all the time is because it intentionally runs slowly, right? Because we don't want it to interfere with the foreground processes and the foreground queries that are running. So that's why it may look like it's always running and whatnot. But of course, in some cases, if you've really made vacuuming aggressive and whatnot, then you may see some correlation between a really fast running vacuum and queries being slower. It can happen, yeah.
Would that also log any errors that happen during auto vacuuming?
Errors should already be logged from auto vacuum failing. If you're seeing auto vacuum failing and it's not logging, how do you even know that it's failing?
We just came across that, as a matter of fact, last week, where there was an index problem, so it couldn't complete auto vacuuming.
And it wasn't logging it?
I'm not sure, but nobody was looking. So
Okay. Well, again, monitor your log files. I think I said that at the very beginning. Yeah, you definitely want to monitor your log files for that. It was almost certainly logging.
you got to get the person who is.
Yeah. It almost certainly it was logging an error in the Postgres logs, because certainly our default would be to log any errors that AutoVacuum has while it runs. But yeah, that's a bad thing, and I've seen that before, and it really, really sucks because it was probably vacuuming that table because it was like the oldest table, and then it keeps trying to vacuum that table, and it keeps failing, and that means that the rest of your system isn't getting vacuumed, and that's bad. That's a problem. So monitor your logs. Sorry. All right. So PG Badger is really, really great. It's really simple to run. You just run it on this, and then it generates a whole bunch of HTML files. I'm kind of running through my time a bit faster than I anticipated, but maybe I'll come back and I'll pull up a PG Badger if we want to look at it. So let me just talk a little bit, though, about understanding some of the different reasons why queries end up being slow. So Postgres configuration issues, of course. Dead tuples and bloat can lead to queries being slower, but it's not actually very typical. Many times it's the query plan at the end of the day, right, that ends up being slow. So let's talk through some of these things. So when it comes to thinking about how to make a query faster, one of the biggest options that is valuable here is workmem. So workmem is the amount of memory that Postgres believes it can use for a given node, right? So when I'm talking about a node, I'm talking about something like a hash join. So how much memory does Postgres think it can use to build a hash table in memory to run through the hash join? That's workmem, or in 15, it's workmem times 2, but still, it's related, right? So if workmem is set to 8 megabytes, and when Postgres is looking at the table size and looking at doing this join, it thinks the hash table is going to be 20 megabytes or something. It's not going to consider necessarily doing a hash join, right? Or it might consider doing what's called a batching hash join. Batching hash joins are unfortunately pretty expensive because what they're doing is they're spilling out to disk to do that hash join, and that ends up being quite expensive. So if your hash joins are batching, or if your hash joins or if you're not seeing hash joins when you're expecting a hash join would be the best, it might be that workmem is too small, right? So increasing workmem helps a great deal with that. Maintenance workmem is kind of related. Maintenance workmem is about things like vacuum and some of the other background tasks. If you're seeing auto vacuum have to do multiple iterations through a table, that can be because maintenance workmem is set small relative to how big your data set is, right? Or how big a particular table is and how many tuples it's having to remember. So maintenance workmem can help with some of that. Effective cache size is also is another really useful parameter when it comes to planning. So what effective cache size in Postgres means is it's the amount of memory that Postgres can kind of hope is being used for file system caching, essentially, right? So effective cache size is going to increase the chances that Postgres will go do an index-based lookup versus doing a sequential scan, for example. And the reason for that is because if Postgres thinks more of the system is in cache, then it's going to say, okay, well, if it's already cached, then doing that index-based, that random lookup, is going to be pretty fast. And so I can go ahead and do that. So effective cache size, and then the other side of that one is random page cost, are two parameters that are really useful to set. and to think about settings. So in particular, if you're seeing a lot of sequential scans and what you are really expecting are index-based lookups, then decreasing random page costs can encourage Postgres to do more index-based operations because it thinks the cost of reading pages randomly is not as expensive as it does by default. So the default is 4 to 1, right? So sequential page cost is 1, random page cost is 4. So 4 to 1 is the default. But if you're on SSDs or the database is such that you can basically fit the whole thing in memory, then you may want to set that down to 2 as a rule generally. Shared buffers is, of course, very, very important. So shared buffers is the amount of memory that is dedicated to Postgres' cache. Right? So Postgres has a page cache. That's where we load up all pages that we use, and then we have basically a clock sweep type of algorithm that will decrease counters to evict pages out. But commonly used pages will be in shared buffers. And if a page is in shared buffers, then we don't have to go out to the kernel to go read it. So if you're operating today with the default shared buffers, you probably are doing it wrong, right? Unless you're running on a phone. So it's a common joke that we have around the Postgres community that our parameters are really decent for today's iPhones, right? And if you're running on a 64 gig or 128 gig server, you probably don't want our defaults for things like shared buffers. Min wall size and max wall size. Again, this is all related to checkpointing and whatnot. If you're seeing log checkpoints coming through, you really want to increase, or due to wall or due to xlog, you really want to increase max wall size. Checkpoint timeout can be a good one to configure. The default is 5 minutes. Increasing checkpoint timeout means that we will spend longer amounts of time writing out checkpoints. Also means that we will write fewer full page images into the write-ahead log. So the first write after every checkpoint is a full page write. Full page is 8K. That's quite a bit larger than a typical row update inside of the write-ahead log. So increasing checkpoint timeout can be valuable. I will say that on the flip side of that, the larger your checkpoints, the longer it'll take Postgres to recover from a crash. Checkpoint completion target, I wouldn't mess with anymore. We actually were able to change the default to this to be 0.9 in, I don't remember when I did that, 13, 14, something like, maybe it was 14. So that one, thankfully, the default is now better on more modern versions of Postgres. But if you still see it set to 0.5, I would recommend increasing it to 0.9. All right, so let's talk about dead tuples and bloat. So the way that Postgres handles updates to records is that we have to mark a table dead or mark a tuple dead, and then that space is available to be reused. That's what vacuum does. We do still have to consider those tuples when we're doing sequential scans, right? And technically in index-based lookups also there might be some, but those are typically not an issue. So one of the things that you can run into is that a table can have lots and lots of dead tuples. Indexes can also have some bloat. And in the event that you're having that, like if the table is 3 gigabytes and there's only 1 gigabyte worth of data and you're doing a sequential scan, then you're spending 3 times the amount of time scanning through that table than you would if the table was perfectly packed, right? A perfectly packed table in that case would mean that you're only scanning 1 gigabyte, whereas otherwise you might scan, you have to scan 3 gigabytes because it's 3 gigabytes in size. I will argue though that don't run out and do a whole bunch of vacuum fulls or clusters or whatever to eliminate all bloat. Some bloat is good, right? So PG bloat check is a useful tool for checking how much bloat you have. Eliminating all bloat does require a rewrite with either a cluster or a vacuum full. But I think the point that I'm trying to make here is that if you go and spend the time to fully rewrite the table, what is going to happen is the next time you need an insert or an update on that table, Postgres has to go and extend the table, right? Extending tables is relatively expensive. So if you're seeing your insert queries are particularly slow compared to before you did this vacuum full or this cluster, that's because those insert statements are now having to go and extend out the relation. That requires an extension lock. It requires going out to the actual kernel and saying, hey, kernel, this needs to be made bigger. And so it ends up being more expensive than if we didn't have to extend it. So when it comes to bloat, don't fret about eliminating all bloat, right? Even 50% bloat, if it's spread out throughout the table and you're doing a lot of updates, is probably not that big of a deal unless the table is terabytes and terabytes in size. When it comes to analyzing plans, there's a few different output options that you can use to get this, and then you can pull those out and put them into some different tools for analyzing those plans. So there was, I think somebody already did an explain talk at this presentation, so I'm not going to go too in-depth with explain itself, but if you have any questions about explain or explain plans, I'll be happy to answer them. Explain.tuples.com is particularly cool. If I have a few minutes at the end, I may pull that up and show you guys. pgadmin 3 and pgadmin 4 also have a pretty graphical thing for looking at explain plans. So how do you fix these slow queries? So there's some low-hanging fruit that I'm going to kind of run through here. So if you're seeing a lot of sequential scans, but you're only getting a few rows returned back from them, and you're not doing, and that's not because of an aggregation, look at creating an index, right? Indexes are really, really helpful in Postgres for doing that kind of lookup. Now, that does involve meaning that you need to create the index based on some kind of column or something that's included as a constraint in your query. That's typically not too much of an issue. I will say here also about indexes that you really want to make sure your indexes are actually getting used. So we talked about this a little bit in some of the other talks. pgstat user indexes will tell you, will tell you when your indexes are being used. And if you have a lot of indexes that aren't getting used, number one, that might be because you went and created like a functional index and you thought it was going to help your query, but it ended up not helping your query. And functional indexes can be a little bit tricky, often because of data type changes and whatnot. So you really want to make sure that if you go create a functional index, that it's actually being used. Otherwise, if it's an index that you just randomly created and it's not actually getting used, then you probably want to go drop that index, because every single insert, every single update, every single delete is having to go and make changes to those indexes as part of the operate. Well, I guess not deletes, but inserts and updates have to go update the indexes, and that's expensive, right? That's not cheap. So when you're worried about trying to improve performance, particularly of write queries, you should be looking at your indexes and seeing which ones are really necessary and which ones are actually being used. A couple other things about indexes is that you can create multi-column indexes. That not everybody is aware of that, but that's really, really helpful for queries that involve multiple columns, right? With a constraint of some kind. Another one is work mem. So there's like a million different reasons to increase work mem. The only reason not to increase work mem is if you start running the system into swap or running it out of memory, right? So I would caution about that though, because remember I was talking about how work mem is the amount for each node. When you have really, really large queries, if you have like 5 or 6 or 7 different tables all getting joined, Postgres is going to consider using work mem amount of memory for each one of those operations, each sort, each hash join, each hash ag, like all of them. So a given query could use quite a few multiples of work mem. So you do want to be careful. So what I like to recommend is that you don't increase work mem too much at the base level, like in the actual postgresql.conf. Instead, what makes sense is that you might want to talk to your application folks about like, okay, for this query, I found out that if I gave it a bit more work mem, it would go do a hash join, and that's way more performant. So what you want them to do is go set work mem right before they run that query and reset it afterwards, so that you don't end up in the potential situation that some query that's already fast enough ends up using a bunch of work mem and ending up potentially hogging memory out of the system. Yeah.
In an application, which would be calling these queries and would be slow, is there a command to actually increase work mem?
Yeah, you just say you do set work mem equals whatever, and that's a SQL query that you just send to the database before you send the next query.
And then when it's done, it will. But that means any concurrent query is also going to be using those. No. So the setting, when you do a set work mem in a given connection, that's only going to apply for that particular session. Okay. It won't impact the rest of the system. Yeah. So PG Bouncer will actually issue a reset, right, between if it's getting two different
If it's serving two different clients that are connecting through PG Bouncer, it'll reset it in between. Now you can change that, but it'll reset it between two different connections to PG Bouncer, right? It'll do a discard all and a reset all and all that. So that I'm fairly sure will actually reset. I don't know. Am I wrong, Bruce?
No, but
Okay.
couldn't you be swapped to another server between your set and your query?
Oh, between your set and your query, if you did them in different transactions, but I don't know why you would do that.
No, I can't remember how PG Bouncer has an aggressive
Yes, okay. So if you okay, so PG Bouncer has three different main modes, right? So if you're using PG Bouncer in the use a different, thing for every single query that you send, you're probably you're probably running functions at that point, right? Because that's certainly how the SkyTools folks did it. I mean, otherwise, how are you going to do that, right? It doesn't make any sense. So if you're doing that, you're probably using functions, and at that point, you would just set workmem on your function. So other cute trick is if you have a lot of functions in the database and you want to change a value like workmem, you can set it on the function, right, itself, and it'll just change workmem for that function that gets called. And that's how you would deal with that case in the super aggressive PG Bouncer mode. But in what I would consider the more typical PG Bouncer setup where you're doing transaction pooling mode, then with transaction mode, you would just need to make sure that you set the workmem inside of the transaction. So you start the transaction, then you set workmem, then you run your queries for that transaction, and then you reset workmem afterwards.
So it was like a select. You normally wouldn't have that in a transaction, but you're actually going to say begin work, set workmem.
If you're using transaction pooling mode, yeah.
Because I remember actually abort the transaction at the end, and if you did this set inside the block, it'll automatically undo it for you. So you don't even have to reset it.
That may be correct. I'd have to go test it, but
An insert, you don't care about aborting it.
right.
Abort the set and it'll roll back the set. So you
Yeah.
don't have to redo it.
Yeah, so that's another possibility. But generally, if you see like a small data set and you're seeing like a lot of sorting or a merge join or something, increase workmem. It's going to encourage Postgres to do things like use hash joins or hash aggregates. So in particular, if you see a merge join happening and you don't think it should be a merge join, you think it should be a hash join, it's very likely that Postgres looked at that and said, well, I'm going to run out of workmem amount of memory in order to do this as a hash join. So instead, I'm going to fall back to using a merge join. Or possibly a nested loop, but more likely it's the difference between merge join and hash join where you'll see that. Other things when you is statistics, right? So if you're having like a large data set and you're seeing a nested loop, you may have an issue with your statistics. And so there's two different options for dealing with that. One is to run analyze, right, and make sure that your statistics are recent. Another thing that you can do is if you have correlated columns, you may want to go create an extended statistics for that particular set of correlated columns. So the way Postgres gathers statistics, we do it on each individual column, and we look at them individually, right? Trying to do every pairing of columns inside of Postgres would create a huge amount of statistics most of the time, which wouldn't be necessary. So that's where it's really helpful for the database administrator to say, oh, these are correlated columns, such as country, or such as like state and zip code, or city and zip code, things like that, right? Those are very correlated. So it's really helpful to have stats for both of those columns in one statistics object. And you can create that today with extended statistics in Postgres. But that's why we don't automatically do that for everything. The other thing that you can do is increase your statistics target or decrease it. I've seen it go both ways. In some cases, decreasing it can actually give you better plans. But more typically, you might consider increasing your statistics target to give Postgres a better idea of the data in that table. Now, all of these cases, though, something to be aware of is that you're going to end up trading some amount of planning time, right, for that runtime. And you want to be careful. If you create like a whole ton of extended objects or extended statistics, the planner has to go consider all of those, right, when it's doing planning work. And you can see how that can increase your planning time. And if your query is already only taking a second or taking 100 milliseconds or something, then that's probably not the best plan because you're probably going to start spending that amount of time in planning, right? Maybe not quite that much, but again, just be aware of the fact that that's something that you're going to have to deal with potentially. Another one that this is one that's kind of a gotcha for folks, right? Is indexes with foreign keys. So if you are seeing your deletes are slow, right? Postgres does not by default or does not require you to have an index on the referring column. Okay? You have to have an index on the referred to column, but not on the referring column. So what that means is that when you go and run a delete on the table that has a foreign key pointed to it, we may have to go do a sequential scan through that other table to find and make sure there aren't any rows there that are going to violate the foreign key constraint, right? After that item's deleted. So you really want to check and make sure that you have a index on, if you're doing cascaded deletes anyway, you really want to go make sure that you've got indexes on all of your referring columns. So Postgres has this thing that kind of seems like it keeps coming up. Prepared queries are certainly helpful in some cases. In a lot of cases, if you prepare it rather, we'll spend some of that planning time up front, and we'll generate what's called a generic plan, and then that'll actually allow you to then reuse that generic plan over and over again, avoiding that cost of doing the replanning. Now, Postgres planner is pretty quick, but even so, all that planning time does add up. Now, Postgres will also do specific plans. So what we'll do is after 5 runs of that generic plan, after 5, what happens is that you prepare the query and then you start running it, right? For the first 5 runs of that, Postgres will actually generate a bit more of a specific plan for that query based on the constants that you've passed in. And it'll say, okay, this ended up running, this ended up being costed at about the same as the generic plan, right? If that keeps happening, then we'll give up on the specific plan and we'll just continue going with the generic plan. Now, in some cases, it turns out that the generic plan, while it came out costed the same or near what the specific plan was actually a much more expensive query plan, right, than the specific plan. In more modern versions of Postgres, you can actually tell Postgres to not do that anymore, to always do the specific plan. I'm trying to remember what the option for that is. Or am I not remembering correctly? Or maybe I just saw a patch for it. Okay, because it's definitely something that comes up. I mean, in a lot of cases, this is like somebody's Java app, right, where the JDBC driver in Java automatically will plan all the queries and then just rerun them. And like the first 5 queries are really fast, and then suddenly it gets really slow, and you're like, what happened? And that's what's happening, right, is this case of, we planned it out for, 5 times, and it seemed like it was, the specific plan and the generic plan were costed about the same. So we're like, well, we're not going to spend that effort of replanning every time. If you see that happening, the really short and sweet answer is don't use the prepared plan for that particular query. Right? Yeah.
What makes a query? How does Postgres recognize that a query that's been run is the same query as one that's been run before? So if things like
when you prepare a query, you have to give it a name, right? Or yeah, I'll just use that example. When you prepare a query, you give it a name, right? And then you say execute that query, right? And that's how it knows it's the same query over and over again. Because when you go to execute it, you just pass in the parameters at that time, and it'll just execute the existing query. So it's not a query cache or anything like that. We aren't doing that. It's a you explicitly as the developer, as the user, actually do a prepare statement. So you send a prepare statement to the database, and then you send execute statements afterwards. You can also use the extended protocol to do the same basic thing. Yeah.
Your memory was correct. Plan cache mode.
Plan cache mode. There you go. That's what it is. So yes. So you can actually you can set plan cache mode if you need to, if you run into this issue now.
So force generic plan or force custom plan.
Yep.
Or auto.
Right. Which is the default. Yep. I don't know who that was. I don't think that was me. That was an interesting noise though. Okay.
And you've got an example on each slide of the prepared
Oh yeah, I do. That's how you do it. That's how you do it if you're running the commands yourself. Again, the extended query protocol allows you to do the same thing, which I believe is what JDBC uses. All right, so a couple other things. Select count star from a table. Indexes can actually help with this. You may not realize that, but Postgres can use an index-only scan to do a count star. Although, really, if you're doing the select count star from tables, you may not want to be doing that. It's just an expensive thing to do in general. Quite often, people run queries like select star from table. That's actually really expensive, right? You don't want to do that. You definitely don't want to return columns back that you're not using. I've seen that happen. You don't want to return rows back that you don't need. But one of the things that people don't realize is that Postgres has a toast system where what we'll do is, in the event that a value is larger than what we consider the toast value, which is 2K, we'll actually try and compress it, and then if it still doesn't fit on the page, we're going to store that out of line, right? So we're actually going to store it in a separate table. What that means, though, is that when you're querying that data out, if you're getting, if you've got like an 8K or a 10K JSON or JSON-B or whatever, and you're just doing these select stars all the time, if you're not using that data when you get it back, Postgres is still having to go to that other table, do an initial lookup on the first table, and then find the toast ID and go do a lookup in the toast table and pull that data from the toast table and then decompress it and send it back to the client. It's just expensive. Select distinct. This is something that, just in general, I recommend watching out for, but also I would say, if you're doing this kind of comma join, you can very easily miss join conditions. And what that means is you'll end up with a Cartesian product ending up being created. And then the distinct will end up going through and removing them. So you really want to be using this kind of join syntax. It's going to make it much less likely that you're going to end up in a situation where Postgres is generating a Cartesian product due to a join condition not being included. So really strongly recommend that you watch out for that. You really want to make sure that you're doing, making sure you have join conditionals for all your joins. A few other ones. So I should really, Bruce's null talk is a great one for this particular slide. In particular, one thing that you can run into is that due to the way nulls work, right, that trinary logic that exists, it's very hard for Postgres to be able to optimize something like a not in query, right? And in some cases, in queries too. So what you really want to do is try to, if you're doing an in, you really want to turn that into a join typically. That's going to be give the planner more options about how to run the query, and typically will be faster. And if you're doing a not in, you really want to either consider using a left join to generate an anti-join plan, is what we call that, or use a not exists, right? And then use a correlated subquery underneath. Using not exists and a correlated subquery is almost certainly going to be better than using a not in clause. So these are, again, cases that you want to watch out for. You typically don't want to do an in or a not in if you can avoid it. Using not exists or using joins are typically better. Yeah.
One of the things that one of our problem queries is we end up doing a select of my in from big table, make a tremendous list, and then we sort of tag them onto the in statement. Is that a bad practice in general?
Yes. That would be my short answer, right? So you're querying the table first, getting a big list of IDs back, and then passing that big list of IDs back to Postgres?
Correct.
That is horrible. So that is an anti-pattern. Like, why is that not a join in the database? Would be the question.
Why
right?
isn't it?
Why isn't it?
I can't tell you.
Okay.
Legacy code.
Yeah.
I just look at the query.
So-
Oh, look at that. That's a
Yeah.
huge list.
So there's actually two things that I want to point out about that. The first is, yeah, absolutely, use a join instead, right? Find a way to push that whole thing to Postgres as one shot and not do that. I don't know why it was like that before, but I wouldn't recommend it. You definitely want to turn that into a join if you can. The other thing, though, is that if for whatever reason you end up having some really, really large list of values that you want to pass into Postgres as a please return all these IDs or whatever, don't use an in list for that, right? Using an array is actually better, right? So, and by array, I mean an actual Postgres array. And the reason for that is that when you use an in list, it has to go through the grammar, right? And the grammar, yeah, okay, it's not terribly slow, but it's not as fast as our array, or the actual array encode, right? When it's parsing an array, that array encode is faster. Just long story short, it is, right? It's faster because the grammar is generic, right? It's got to be able to handle anything kind of thrown at it, and so it does a whole lot of other stuff in terms of setting up everything, and it actually, like, for each one of those values, it has to construct a node and all of that kind of stuff. So it's a lot more efficient to pass arrays into Postgres when you're doing that kind of a big list of items that you want Postgres to go find.
So just generally speaking, seeing a in statement should be a red flag for.
I mean, if it's like a really small thing, or if the query is always fast, then like who cares, right? I mean, this is all about like once you've identified that query as being slow and problematic, then if it's doing an in one, that's like a trick. You say, oh, let me see if I can get rid of that in clause and make that into a join, or if I need to have a big in list, I can turn it into an array. Yes, Bruce?
Sometimes the common table expressions will help you here too.
Yep.
So you actually take the subquery into the in, it becomes a common table expression, and then it joins or feeds into the other. So I'm not saying which one's better, it's almost hard to tell sometimes.
Yeah, but I mean, I would still, at least for the case you're talking about, I would still recommend just seeing if you can turn it into a regular join. Yeah, common table expressions are very helpful, though, certainly, and more modern versions of Postgres will do a full optimization, including the common table expressions. That's actually another trick, though. If you are ending up in cases where you have a CTE and and you have a regular query, and for whatever reason, once Postgres optimizes the whole thing, you're getting a plan that you don't think is great, you can try doing, if you pass in the materialize keyword to the common table expression, Postgres, that'll force Postgres to go and optimize the CTE independently of the rest of the query. And what'll happen is that it'll optimize and then run the CTE and then cache that result, right? And then, pull it into the regular plan. Upsides and downsides to that, right? It costs something to cache that information, right? But if it's a relatively small amount, then it could be beneficial, right? And it may avoid whatever the issue is that you're having with the optimizer trying to do a full optimization on the entire query. So that materialize keyword is another one that's really handy when you're dealing with query plans and fighting with them and whatnot. So when you're doing CTEs, I typically would argue to keep the results of them small. This is especially true when you're doing a materialize, though, right? Because the results of that, when we cache it, we don't index it at all, right? And so without that index, individual lookups into that results of that CTE have to scan it. So that can end up being kind of expensive. If you really, really want a super fast count star, just go look at the database statistics, right? We already capture an idea of what the number of tuples are in the table. You can just go look at PG class rel tuples, right? Again, it's not super accurate. It's only updated when we do analyze and things like that. So, and it's only useful for the whole table, but you can use it if you want, right? The other thing that you can do is, obviously, we collect a bunch of statistics, so you can go look in the PG stat tables if you want some idea about like what the most common values are in the table or in the particular column. You can just go pull that from PG stat statistic instead of or some PG statistic, I should say, instead of actually querying the database for it. But again, that information is only updated with every analyze, and so it may not be accurate enough for what you're doing. It really depends on what your use case is. So, again, increasing work mem and maintenance work mem, setting effective cache size, and increasing shared buffers. Those are all, very memory-oriented things, but those are things that are going to help you out with your queries quite often. Partial indexes and functional indexes, I mentioned them a little bit earlier. Really, really helpful to have. With a partial index, it'll index only part of the table, which can be really handy, particularly if you have like a very common value, right? A great example is like an orders table. Right, you have an orders table, and you have orders that go through a progression, right? You have a new order, you have an in-progress order, you have a completed order. Well, that orders table is going to end up with a whole bunch of stuff in completed eventually, right? And so what you may want to consider doing is creating a partial index on the orders table where that order status is you're only indexing the new and the in-progress ones. Okay? And because you're only indexing new and in progress, any query that comes in and says, give me the new orders or give me the in progress ones, can use that partial index, which is going to be way, way, way smaller than a complete index across the entire table that includes all of those duplicate entries for the completed orders. Now, I will caution you about this, though. Just like with functional indexes, you need to make sure that those indexes are actually getting used for the query. Because one of the problems that I've seen is people will create an index, and they'll do like a, I want an index on not completed. Now, that's actually an index that's very hard for Postgres to actually be able to use. Right? We'll let you create it, but in terms of actually planning the query out, planning a negative like that is hard, right? And we have to be sure that we can use that index when or we have to be sure that the index will have all of the rows that are valid for the query, right? In order to be able to use that index. We must know that. Otherwise, we don't think we can trust that index, right? Because it's a partial index. That's part of the point. So that's why you don't want to use a negative in a partial index, right? What you really want to do is create a partial index on the actual values that you know you are going to be looking for in your select queries. And of course, removing unused indexes, right? So unused indexes, as I mentioned before, and as we've talked about, still have to be maintained. And that means, the more indexes, the slower of minutes here in terms of for questions. I know you're not, I technically have 4 minutes according to my watch, or maybe I'm 6 minutes over. I don't know, one of the two. Any other questions? No other questions? Nobody? Nope. Nope. So here's the thing around it, right? So we basically consider hints to be essentially giving up on the optimizer and saying that, it's not good enough or it's not doing its thing right, which, yeah, sure it is. And so we don't have a hint system in Postgres. What you can do instead is you can play around with tweaking things like random page cost, right? CPU tuple cost. Some of those other things can be useful for tuning. I would be very cautious about those planner tunables, especially on, I wouldn't tune them in postgresql.conf, right? Just like with workmem, if you go and set CPU tuple cost inside of a session, it's only going to be set for that session. And if you, do it right before you run a query and then reset it afterwards, it'll only apply for that query. So those are parameters that, yeah, you can tune if you need to, but I would do it on a kind of a query by query basis. I would strongly avoid changing things like CPU tuple cost in postgresql.conf. But they can be helpful in other cases. Of course, if you're having to do that, yeah, maybe using hints would have been easier. The downside of using hints, though, of course, is that data changes. It's not always going to be the right answer to do a hash join with that thing, that part of the query. And so having a hint that forces it is really, you're really kind of tying the optimizer's hands at that point. And that's part of the reason why we don't have a hint system. I don't know if you want to comment any on why we don't have hints.
No, you're right. I think the real value is, the major value I've seen is if something's not working right, you don't have time to find the cause, you're in production, and you just want to push out a query fix real fast that forces it to do something for the rest of the day. That's a good use. But the problem is that's also misused. And then that's...
And forgotten.
But the real, when you start talking about, okay, maybe we need to adjust random page cost is wrong, maybe it's effective cache size, maybe it's the statistics. When you start to go to those type of solutions, you realize that you're affecting you're improving broad categories of queries.
Yeah, yeah.
You do random page cost, every query is going to be affected, right? You do statistics.
If you set it in, if you set random page cost in the configuration.
What the right value is,
Yeah.
you set across all sessions, you're improving broad spots.
Right.
When you change statistics target for a column, anything that references that is going to have to be statistics, right? So, effective hash size is going to be global across the whole thing. So the idea is that instead of trying to force to sort of jam
Yeah, just to repeat that for the recording, it's what Bruce is talking about is rather than playing whack-a-mole fixing individual queries with hints, it's more effective to fix the model of the system by changing things like random page cost system-wide or effective cache size system-wide, because then you're gonna benefit all the queries, right? Or changing the statistics target on a particular column, that's gonna benefit all of the queries that are used in that column, and it's a broader answer that solves more problems, right? Rather than having to play whack-a-mole with all those different queries.
I just feel like it's a bit of a whack-a-mole trying to find the right indexing on some of these very, very large tables. It's very difficult to play around because the indexing of the table itself can take hours.
Yeah. Figuring out what the right indexes are can be challenging.
When you're not sure if what you're going to do is ultimately get
But
picked up by...
yeah, but I mean, hints aren't going to help you with an index problem, right? If the index doesn't exist and you got to go create it one way or the other, that's not a hint type of thing, right? So.
Right, but if you create an index and then you're surprised, which obviously I am, that it's not being picked up, that's why I was asking about that. And say, hey, there is a
But even in that case, it's very likely that the reason we're not using that index is that there's a reason why we can't use that index is more likely, right? Again, it's a partial index where we can't prove that partial index predicate is actually matching the rows that the query is matching, or it's a functional index and there's some kind of mismatch with the data type or something. If Postgres is gonna, if the index is actually valuable and exists and is there and is something we can use, we're very likely going to use it, right? The only other case I would argue with that is when you have a case where, for example, you create an index and Postgres is like, well, we're going to end up touching every page in the table anyway, therefore the index is not going to be helpful. That's something that could be helped by increasing effective cache, right? Or decreasing random page cost, either one. Because that's going to be like, at some point we're going to be like, oh, well, maybe it does make sense to use this, right? And again, though, like, if you're finding that setting random page costs lower for that one query is helping, it's a good chance it's going to help more queries on the system, and that may be something you want to go set across the board. But if you're, at the end of the day, if you're pulling out more than a few percent of a table, chances are Postgres is right to do a sequential scan. You really have to be searching for a very small subset of records in order for indexes to be better than a sequential scan. Even on SSDs and stuff, even those sequential scans still can go through data faster than a random scan. Yes.
So thinking holistically, if I had to work backwards, say I was given a certain server size with 256 gigs of RAM, and it's going to be an OLTP system, do you have a rule of thumb of what to set certain settings?
Yeah, I mean, these days I would say you can go up pretty large with shared buffers. We've made a lot of improvements in dealing with that. On a 256 gig box, shared buffers of 64 gigs and effective cache size for the rest. Something like that might be, or maybe even 128 gigs for shared buffers possibly. There are a few cases, although I think we fixed some of them, but there are still a few cases where we have to actually, for a certain operation, we might have to scan all of shared buffers. I think truncate still requires that. So, like, if you're doing certain operations that you want and expect to be really fast, and you go up really high in shared buffers and suddenly they're slow, that might be a case where we still have to scan all of shared buffers for that. But it's pretty atypical. Usually increasing shared buffers is beneficial. So it depends also on how large your queries are, but on an OLTP system, your transactions and queries are typically going to be pretty small. So you don't have to worry too much about how much backend memory you have. But do realize that the more backends you have running, right, the higher max connections is and the higher number of connections you have, each one of those has got some amount of cache that is in it, as well as having to do the query processing. And so those, that amount of memory can definitely add up over a long period of time. So that's something else to just be aware of. So anyway, I'm losing people, and I know we're past time, so I'm going to call it at this point. But you guys feel free to come up and ask me any questions you have. Thank you all so much.